Okay, so here is another type of question. This question says, if we have a function defined implicitly, like this one, x squared plus y squared equals 4, how do we find that function's second derivative and have that in terms of x and y? Okay, so we're not actually going to be able to use the second derivatives of these for very much, but it's still a very helpful technique to practice this implicit differentiation. Okay, so to find the second derivative, let's start by finding the first derivative, so then we can find the derivative of that. Okay, so we get 2x dx dx plus 2y dy dx equals 0. Okay, we can get rid of that dx dx. We're going to take this 2x over here, so we get 2y dy dx equals negative 2x. So then dy dx is going to equal negative x over y. Okay, so there's our first derivative. Okay, so now our goal is, what we're going to do is we're going to try to find the second derivative and express that in terms of x and y. Okay, and we'll see what the problem is in just a second. Okay, so when we want to take the derivative of this function, we're going to need to use the quotient rule. Okay, so we do low times d high, negative 1 dx dx. Oops, sorry, this is d squared y dx squared. Okay. Minus high, negative x, below 1 dy dx, all over low squared, y squared. Okay, now here's the problem. We have a dy dx right there that's messing things up. Otherwise, everything else is either an x or a y, right? Y times negative 1 minus negative x, y squared. Everything else is an x or a y. But here's the thing. We know what dy dx equals. So dy dx, in this step, we learned was negative x over y. So what we can do is we can just plug in this negative x over y right into dy dx, and then everything will be either an x or a y. So let's try that. So we have d squared y dx squared is going to equal negative y minus negative x, so plus x times negative x over y, all over y squared. Okay, so then this equals negative y minus x squared over y, all over y squared. Okay, now we would never really leave an expression like that. That's a very, very messy thing. So in order to get rid of that complex fraction, we can do one of two things. Either we can combine these two up top and then divide, or we can just multiply by y over y. And that will clear out all the y's from up top, from the denominators up top, without changing the expression. So then our final expression equals negative y squared minus x squared all over y cubed. Okay, so let's try that one more time, except with, if that was perfectly okay for you, then you can stop the video now. But if you'd like to see one more example, then I'll try that with one more example. Okay, so here's our second example. Draw a line right here. So we get our second example is y squared equals 10x. Okay, so let's take so we want to find, again, our goal is to find the second derivative, okay, with only, only in terms of x and y. Okay, so let's take the first derivative again. So we get 2y dy dx equals 10 dx dx. Okay, and I almost guarantee you're not you're done writing dx dx's, but that's okay. I'll still keep writing them. Okay, so let's solve that. So we get dy dx equals 10 over 2y, which is the same thing as 5 over y. Let me write that a little bit better. Okay, so now we want to take the second derivative of this. And there's a couple different ways to do this, but some would be much better than others. For example, you might look at that and think, okay, that's one thing divided by another thing. Quotient rule is going to be the best. But actually, that's probably not the best way to think about it, because we could actually look at this as 5y to the negative 1. Okay, so now if we do the second derivative, d squared y over dx squared, okay, we're gonna just use the chain rule. Okay, so, and the chain and the power rule. So we get negative 6, sorry, whoa. Negative 5 y to the negative 1 minus 1, which is negative 2. And then remembering that using the chain rule, how is that derivative, dy, changing with respect to x? Okay, now again, just like before, we have this problem because this term is not in terms of x and y, but we already know what it is, so it's very easy to put in terms of x and y. This is 5 over y. Okay, so let's just plug that into the expression. So we get negative 5 over y squared times 5 over y, which equals negative 5 over y cubed. And there is our second derivative, only in terms of x and y.